All right, hi everybody, welcome back to this channel. Thank you very much for joining me once again. We are still continuing with revising your trial past exam paper, and today we're going to be looking at the 2024 pre-trial exam from the Mpumalanga province. Okay, so we're going to look at this question on trigonometry. Guys, if you are new to the channel, please make sure that you have subscribed, turn on that notification bell so that you can be notified every time when we upload a new session. Without wasting any time, let's get into it. Okay, interesting question. They are saying given P is equals to the square root of sine x times cos x. The first question is saying we have to determine the maximum value of P. Okay, so that's the first question. Determine the maximum value for P. Okay, how can we get the maximum value? So, I've already shown you on some trig function that there's a formula. It's not in your textbook, unfortunately, that enables you to find the maximum value of any trigonometric function in the form of a let's use sine x minus p plus q. Okay, so long as you can identify a and q to get the maximum value, I've already shown you in another video. If you didn't watch it, guys, please make sure you go and watch it. I'm just gonna drop the link of that video on the description. Okay, so to say maximum value, you just take your amplitude plus your vertical shift, because we do know that the amplitude will be stretching the graph vertically like that. Okay, so that is your vertical stretch, right, as you increase amplitude. And Q now will be shifting your graph up, going up, or shifting it down depending on whether it's positive or negative. Okay, so in that case we recognize that the maximum value of any trigonometric function would have been affected by A, which is the amplitude, and the shift, how have you shifted it up or down. So to get the maximum value, you just say A plus Q. Okay, this formula is not in the textbooks, right? I hope you find it very helpful. So the minimum value, you just take negative amplitude plus Q, right? Because if you check the sine function, its amplitude, it's obviously, if you have the graph of y equals to sine x, as I've shown in the previous video, amplitude is 1, right? But if you need the minimum value, so Q is 0, if you need the minimum value, you say negative 1 plus 0. Then the minimum value of this graph, sine x, it turns at what? At negative 1. So that's the idea, really, right? So in this question, we need to find the maximum value of P, right? Firstly, I'll try by all means to express my function in this format so that I can easily identify amplitude and Q. At this point, it's not in the format, right? So what we can do is I'm gonna apply this the square both side, right? I'm squaring both sides to remove that square root, right? So that I'm having nice function, right, without the square root, because maybe that can confuse you. But you can still solve it with the square root. I'll show you two ways, right? So if we square both sides, we do know we'll have p squared is equals to the square root will go away, right? We have sine x times cos x. Okay, you recall that this is coming or similar to the double angle of sine, right? Remember, if you have sine 2x is the same as 2 sine x cos x, right? So if I'm solving for sine x, I divide both sides by 2. You recognize that from the double angle of sine, so sine x cos x will be basically 1 over 2 sine 2x, okay, or sine 2x divided by 2. So I can now come and replace here, right, or show them the rule really to say actually if I multiply this with 2, it will be 2 sine x cos x. But again, I need to remove these 2, right? That is divide by 2 so that the 2 and 2 cancel, right? Like that. So you realize that this is actually now a rule, right? Which is sine 2x divided by 2. Okay, so now in that case, my p squared is the same as 1 over 2 sine 2x. My function is properly in a way that I need it. So you can see that the q here is 0, right? Amplitude, it's 1 over 2, but my q is 0. So the maximum value of this function will be a plus q, that is half plus 0. Okay. So this will give me p squared is equals to maximum value of this one. It will be 1 over 2 plus 0. That is a plus q. Then you have p squared is equals to 1 over 2. So the maximum value of p, they didn't say p squared, they said maximum value of p. I'm just going to apply the square root both sides, right? So p is equals to the root of 1 over 2. That will give us the maximum value of p. Okay, so this is just the first method. Let me show you the second method quickly. Okay, with the second method, we do not necessarily need to apply the to square both sides to remove the square root. We can simply convert this into a single trigonometric function, because we recognize this is coming from a rule, which is the the double angle of sine, right? So we can say p is equals to the root of, so if I now want to write this as in terms of sine only, so you do recognize that I can simply multiply by 2 and divide by 2, right? It's like I'm multiplying by 1 that expression sine x cos x, right? 2 over 2 is 1, so it's like we didn't change it, but then we recognize this is coming from a rule, right? So p equals to root of this will be 2 sine x cos x, so that you clearly see it over 2. Then if we simplify, this is the double angle of sine, so it's sine 2x divided by 2. All right, so in that case I can write it properly so that you can see it's 1 over 2, sorry about that, sine 2x. Okay, so now you can see, you can identify your amplitude, you can also identify your q, which is 0, right? There's no vertical shift here, so you just have amplitude, so maximum value will be 1 over 2. So the maximum value of that is what? It's 1 over 2. Then you have actually find the maximum value of p, which is the square root of 1 over 2, right? So this will give us 0.707 like that. Okay, so that will be the maximum value of p. All right, I hope you find this helpful. Let's go to number 2, determine the general solution. We have already quite simplified, but let me just show you quickly so that you are aware of these rules and how to really do it properly. All right. So number 2, they want you to find the general solution of this expression. We have already seen that this is actually the same as 1 over 2 sine 2x, right, is equals to minus 0.24. So to cancel this 1 over 2, you can divide both sides by 1 over 2, you know, or someone can say we can simply multiply by 2 both sides, right? So minus 0.24 divided by 1 over 2, which is the same as multiplying it by 2, it will give us negative 0.48. This is equals to sine 2x. Okay, now we can apply the general solution, guys. So remember, for the general solution we need the reference angle, right? When you get the reference angle, you don't consider the negative here, right? So the reference angle will say 2x is equals to arc sine of 0.48. Take notice, I didn't include the negative because now we are looking for the reference angle, right? The negative will only tell us which quadrants we go to find that general solution. So I'm saying arc sine of 0.48. So this will give me 2x, which is my reference angle, is equals to 28,685 degrees, right? Then the negative is informing me that my answer is going to be on the quadrant where sine is negative. Okay, we know that sine is negative on the third quadrant and on the fourth quadrant. Okay, so where the third quadrant is defined as 180 plus your reference angle, right? Then fourth quadrant is defined, plus theta. In this case, theta is our reference angle, or plus x, like that. So fourth quadrant is defined as 360 degrees minus theta. Okay, so I'm going to this quadrant to now finally find my general solution. So the third quadrant is defined as 180 degrees plus theta. So what I will do is I'm going to say, remember this is my reference angle, so it's 2x is equals to, I will say 180 degrees plus this reference angle, which is what, 28,685, right? Remember it's sine plus k times 360 degrees. So that is how I would find the general solution. We go to the fourth quadrant, we have this one. So we say 2x is equals to, remember fourth quadrant is 360 minus theta, which is my reference angle. So I have 2x is equals to 360 degrees minus my reference angle 28,685 degrees. Okay, so plus k times 360 degrees. Guys, a lot of you tend to make a mistake on this step of finding the reference angle. You'll find people dividing by 2, right? Very important, you don't have to do it at this point of finding the reference angle. If it's sine 2x, as we saw, sine 2x was equals to 0.48, negative 0.48. To get the reference angle, we just say 2x equals to arc sine of 0.48. Whatever answer you get here, that is your angle there, right? You don't have to divide at this point because it will affect your domain that side, okay, because it still need to be divided by that 2. Okay, so we can simplify now. We can say 2x is equals to 180 plus 28,685 is gonna give me 208,685 plus k times 360. Okay, so this side on the fourth quadrant, 2x is equals to 360 minus 28,685. So it's gonna give me I can't see this other number, let me check. So it's 331,315 plus k times 360 degrees. Then to finally find the general solution, I divide both sides by 2, everything including that domain there. So x, it's gonna be equals to, it's 208,685 divided by 2, which is gonna give me 104,34 plus k times 360 divided by 2, it's 180, where k is the element of all integers. Okay, so that is our first general solution there. This side on the fourth quadrant, we're gonna divide by 2, divide by 2, divide by 2. All right, so x, let me use a different color, maybe x will be equals to, it's 331,315 divided by 2, which is 165, okay, so this is 165,66 degrees plus k times 360 divided by 2, 180, where k is the element of all integers. Okay, so that it will be our general solution. I hope you find this helpful. Don't forget to like, share, comment, and subscribe. See you soon. Bye.